in our studio how to commit our changes and then also push them to our GitHub repository. So I'll be showing you how to create a GitHub repository too. But before that, we are going to be creating a new project, and with new directory, we can say new project. And then you can enter anything you want. For example, I can choose the exercise 3 from here, and then I can create a new directory with this, and we are going to be clicking on create a Git repository and use renv with this project, and you can install the required packages, and we are gonna be creating this project. If you don't want to lose your current screen, then you can say open a new session, but I'll be changing my current screen. And now we are done. So in the next step, I'll be showing you how to create a GitHub repository. Account, you can create new, click on new here to create a new repository. You can name it anything you want. I'll be naming it exercise 3 YouTube. And for making it simple, we're just gonna be creating it without adding a readme file, because then it's easier to push an existing repository if we had code or creating a new repository. But I'm gonna be copy pasting this git remote at origin, and I'll be back with our code. In our markdown file, it also required me to install some packages, but it installs them automatically. You just have to accept it. If this happens to you too, you can just come back to tutorial after installing the required packages. Then it will be better for you to install them completely one time than installing them one by one during the tutorial. So I'll be naming it exercise 3. And here, let's delete these unnecessary things. So first of all, we are gonna be starting with the Boston dataset. So for that, we are gonna be either, if you don't have tidyverse, you can install it, but I have it, so I'll just call it with library. Tidyverse makes it really easy to, change, for example, numbers to the dates, and also other kind of dataset operations where we want to modify the dataset, and we're gonna be using it, and you can see how it makes things much more easier. So for the Boston Marathon winners dataset, it's normally in Kaggle divided into two: men's Boston Marathon winners and women's Boston Marathon winners datasets. So I'm gonna be combining them to get a more broad view. So let's read it as men marathon. We are gonna be calling read.csv, and then and also the women marathon. I'm just gonna be copy pasting this. Okay, now after we read them, we are gonna be adding a gender column to each dataset to identify if it belongs to a male or a female. Normally you can think that this isn't necessary because it's easy to identify the name of a man from a woman, but when we're gonna be, for example, comparing both winners, we are gonna be needing this gender column, because this is not an AI problem where we can identify by name, so we are gonna be identifying by column. For that, we are gonna be using tidyverse. For tidyverse operations, we use this operator, and it just combines different steps, and there we're gonna be calling the mutate function, which changes the dataset basically, and when we enter gender equal male, it will be creating a gender column and filling it with male. And then we're gonna be doing the same thing for the woman marathon dataset. Then we can combine both datasets, but before that, maybe it's better to show you the dataset. For example, from women marathon dataset, we can look at the head, and then for both of them, actually we can look at the head after changing the dataset, and then we'll be able to see the difference too. and you'll be able to see that they both have the same column, so it's easy to combine them. So let's run this. By the way, it wasn't installed in my system too, so I'm gonna be installing with you. So it's gonna be installed in a few seconds, I think, and it installs its side packages like dplyr too. At the meantime, actually, we can continue with the code and then come back and run these. It will be much better. So now, actually, we were about to combine both data sets. So let me delete this. Now for combining, we'll just say bind rows as they are both same columns, and I'm gonna be calling it Boston Marathon. And then we can check the data set using str function. You surely remember it from the previous session exercise 2. It just summarized the data set. So after this, we can continue with the code, and we'll commit the changes later together. Then it was a problem in the run, sorry for that, for the package installation. So next we'll convert the time format to a numeric format that can be easily analyzed. For that, actually it's better if I show you the data set from here. So we have this time column just before the distance miles and distance kilometers. For that time, we'll extract the hours, minutes, and seconds and convert them to a single numeric value representing the total minutes. Let's quickly do that. And we are gonna be using tidyverse again. And let's call the mutate function to change the dataset. And for that, we can create a new column, time numeric. Oh, it just finished, by the way, and we can quickly look at the things. So to the data frames, this is for the women marathon. Yes, we have the year, winner, country, time, distance in miles, distance in kilometers, and the gender column. And then for men, we have the same things. The only difference is the gender column, it's male. Then we can continue by combining them. And now you can see the summary of this here. And it says for gender, for the first 7-1 male, because we first put the men marathon and then the women marathon. And for better visualization, you can look at the head again, and it's the same. And also the tail to see that the women marathon has been added to that. And here you can see it. And we've got also some NAs. So we need to look at that too. When we are actually changing the numeric ones, we have to see if we have to like skip the NaN ones, and we can also delete them too quickly. We'll call the function na.omit here after binding. And we are gonna be entering the same data set. And now we won't be seeing the NA. Yes, it has disappeared. That's good. So for time, I'm actually thinking of turning it into, hours, turning the hours, minutes, and seconds into total minutes, because we'll be easily then able to calculate the average meaning time. So let's write a function for that, and you'll be able to see how to write functions in R2. I'll be calling it convert time to minutes, and I'll be calling the function, and it will take the time as string. You can put any parameter name here as you want. And then first we'll be splitting the time string into its components. I'll be calling it time parts and string split. By the way, I forgot to mention it here in the summary. Yes, to be sure, if the time column was a string, you can look at the data types here, and as we can see, it's in character, so it's string. It's better that way. And now let's split it. We are taking the parameter we entered here to the function, and then we'll be splitting it from this character. As you can see, it's split from double dots, and then we are gonna be taking the first element from it. Now we can extract hours, minutes, and seconds. We'll be converting it to numeric from string. And this is the first element. Now we can copy paste this and then change it to minutes and seconds. And now it's time to calculate the total time in minutes. So for that, what I'm gonna do is basically multiplying the hours with 60, because as we all know, 1 hour is 60 minutes, and then adding the minutes to it. So it's so simple. And then dividing the seconds by 60 this time, because 1 minute is 60 seconds is the reverse. And then I'm gonna be returning the total minutes. And this was the function. Now to apply it to Boston Marathon dataset, we'll use the tidyverse library again. And call the mutate function. And now we'll create the column time numeric, or we can just, I think, apply to the same column too. This function with sapply, this will apply this function to all the values in this time column. And let's see if it works. Now when we look at it, let's change it to a new column. Maybe it will be better that way to see. Oh, sorry, I changed the wrong thing. I think it has already changed it. Let's check it from here. I'll just copy paste this. Or what you can do is, actually, you can run all of this again to return to its original version, and then let's try with the same column if we can see it. And we are first waiting. Oh, it's installing again. Normally it shouldn't install, it should just go, so I'm gonna be stopping it. Now it's working. Let's come here. So now we can see that, yes, indeed the time column has changed to minutes. That's good. And then now we can continue with the other steps. But before that, I just want to quickly show you how to commit these changes. If you go to the Git part here, you'll see that all these changes have been stored here. And then we are gonna be adding them with the command git add dot. Oh. Normally it should add, but it doesn't seem to recognize it. For that, we can just add from here too. And then just click on commit. Normally it should work from here too. We say, for example, intro. Oh, the most confusing problem with Git is the problem that we can confuse the console with the terminal. So the only problem was here that I forgot to use the terminal for it. We always need to use the terminal to commit our changes, or like work with Git basically. So now when I do that, it works here, and then when I say commit, and I can say initial steps, for example, and I can commit them, and here we can see them committed. And here you can track the committed things basically. Now it should be fine because we can now see nothing that needs to be committed, so we can continue with the code. I'm gonna be copy pasting this, and the next step we are gonna do is calculating the average winning time, and for that I'm gonna call this variable the average time. We are gonna be calling the mean function, and from the Boston Marathon data set the time column. And if we had NA values that we didn't remove, then we could have also said NA.remove true, but in this case we don't need it anymore as we've deleted them with NA.omit function. So let's print it. You can either print this or just write average time too. It works fine both ways. And here we can see that the average winning time is 145 minutes in total. And let's move on now. I think it's finally time to plot something so that we won't be bored from the code. So now we are gonna be plotting the trend of winning times over the years. For that I'll be using ggplot and as data Boston Marathon, and inside the aesthetics we'll plot as x the year, here you can see it, and as y the time column. And we can, for example, enter as color the gender so that we can see the trend in male athletes and female athletes and compare them. Then we can add a line, geom line for the trend. And when we add a geom point above the line, we'll get these plots where above the line there are points. I'll be showing the difference to you too, so that you can understand better. We can put here GG title, for example, trend of winning times in Boston Marathon over the years, or you can also come here and as this is a figure you can say fig.cap and enter the caption here too. You can go more into this. There are a lot of fig.cap options we can use for visualizing our plot better. Trend of winning times in Boston Marathon over the years, and we can enter the x function label as year and the y label as winning time minutes, and then let's run this. And as I mentioned, for example, if we delete the geom points, you can see it's just lines, but with points it's better looking. So here you can see the change in winning time over the years, and there is a trend, decreasing trend, as we can see. So as the years pass, the winning time decreased, which is good because in these kind of sports competitions, especially for running, you have to run fast in a short time to win. So here we can see that trend, and the male athletes tend to run the same kilometers in shorter time, as we can see from here. And let's continue. Now I want to come to another point. So just out of curiosity, let's identify any anomalies in the winning times. So anomalies are data points that deviate significantly from the norm. If we use here the z-scores to detect these anomalies, the z-scores measures how many standard deviations a data point is from the mean. if you have taken any statistics course, you'll be able to know that, or maybe you've heard of it. It's a common thing used for deviations, especially. For that, I'll be using tidyverse. So you can easily do any statistical operations in R. R is a real suitable language for that. And we're gonna be calling the mutate function again, and inside it we're gonna be adding a z-score column. So there isn't any specific z-score function, so we'll be writing it, which is better for times to understand the logic behind it. So first we are gonna be subtracting from the time column the mean of the time column, and then we are gonna be dividing this to the standard deviation of the time column, which is found with SD function. And that's basically it. We can create another variable named anomalies and use tidyverse again to filter the dataset according to the z-scores bigger than 2. So with absolute, we are turning the negative values to positive ones too, or 0 to 0. So for that, there are some that are below the mean, which have negative values, but you know, the bigger the negative values get, they form also the anomalies too. So to the negative side and both to the positive side, the values very much above the mean and very much below the mean create these anomalies. So we are taking the absolute function to also consider the anomalies of the negative part too. Now we can print these anomalies. So I think you realized my mistake before me. I had to just take the absolute of the z-score. Now this should work. Yes, now it worked. And as we can see, these are basically the anomalies. As we've calculated the mean before here, I think it was 145. Yes, this was the mean. And here we can see that these are really above the mean. And we can see the z-scores here calculated. And if we look at the these are basically the anomalies. Yes, we have just 8 rows for that. So these are all above the mean. So we didn't need to actually take the absolute, but just for security reasons, we always take it, because we can know if there are some below the mean too. So this was all from the first exercise. Now let's also commit these changes. But we need to first save it, because without saving it, then we won't be able to track these changes. Let's say exercise 3 solutions. And now we'll see the changes. And let me say, oh, now we are in terminal, that's good. And let's commit this as first exercise completed. And then as we can see, it committed them. Now it's gone, amazing. And when we click on the commit, there isn't any change. Oh yes, now we can see it. I was looking for this. So as we can see, we can track our changes from here. First we set initial steps, but my bad, we forgot to save it, so we didn't see any change here. But we can see all the changes from here, as you can see. So it's good to be able to track them. And if we accidentally change anything, like delete this, for example, and then save it, and then can select it, add, and git commit and accidental change, for example. And when we go into changes, we'll see that it shows that this has been changed. And we can, for example, come to here and then copy paste this, or at least see our change from here to here. So it's good to basically track all these steps. Now let me close this. Oops, sorry. Now it's closed, amazing. And I can take this back, save it again. But let's move on to the second part of the exercise 3 now. Now we'll use the Amazon Kindle Books dataset for 2023. And let's start by loading the dataset. I'll be giving it a new header, exercise 2.2. And did we give it to here? We didn't. Let's give it to here too. Exercise 2.1. And we can remove this too because we don't need a cap. And here too, let's remove it. And I'm gonna be calling this Kindle books. And then let's read CSV file. It's Kindle data v2.csv. And then let's look at the summary of this to see if there are any inconsistent data or missing data. And now we can see from here so there isn't any inconsistent values as I've seen here, because the price isn't negative, for example, which could be an inconsistency, stars neither, and the price can be 0 too for free books. But if you want to just consider the paid books, you can always use tidyverse as I've shown you to filter the dataset for price bigger than 1 and also stars more than 1 too. And now I think it will give a better view to us because we can see the cheapest book. And now the cheapest book is 0.50 in dollars, I guess. And then the minimum stars is 1, as we know. And let's continue with the second one. Before that, let's commit this too, but I'll be deleting this. And let's save it and come here and say it at, for example, dataset loaded. And now we can see the changes here. Actually, it should have appeared there, but sometimes it takes some time. Oh yes, they came. They are here. Dataset loaded. Amazing. And now let's go with the second step. After cleaning the data, we can analyze the distribution of book prices. So for that, I'll be creating a histogram and calculating the average price of a Kindle book. Here, the histogram will help us visualize the distribution of a numerical variable, in this case the price. Let's first calculate the average price by calling the mean function and taking the price column. And just to be sure, we don't know if there are any non-values, I've said na.remove true. And in R it's written in full capitals, and we can look at this average price. And then first let's look at it. It's 15. And now we can plot the distribution using ggplot, Kindle books, and then aesthetics. And as x-axis we'll be giving the price. And for creating an histogram, we'll call the geohistogram function. And we can assign the bin width also to anything we want. For example, let's start by 1. If it's too small, we can adjust it. And for title, let's do this time with gg title. As you know, you can also do it by using fig.cap. And we'll name it distribution of Kindle book prices. And let's give the label for the x-axis. It will be price in dollars. And for y label, normally in histograms we usually give it frequency. And when we plot this, oh, it's so small, let's give it 30 maybe. Now it's much more better. Maybe 300 will be so much. Yes, now it's so much. Let's give like 100. Now it's somewhat better, but the problem here is that because most of the value, like the prices, are centered around 0, and like smaller than 100, and there are so little books that have priced around 200. We can maybe concentrate this plot by limiting the x-axis. Identify the top 10 highest rated books with at least 50 reviews. The summary table will show the title, author, average rating, and number of reviews for these top books. Let's start. And we are gonna be using the tidyverse again with this operator. And now we are gonna filter the data set with reviews more or equal to 50. And now let's arrange, basically sort the data set in a descending order using the stars. You can also do it by ascending if you want to see the worst books. And then we'll be taking the top 10, so head 10, and it's basically like SQL now. We're gonna be selecting the columns we wanna take, which are title, author, stars, and review. And now we can look at the top books. And the titles here. Actually, as you can see, Python, the most popular language, and AI has entered this list, so these are really popular these days. Then we have the authors, the stars, which are 5 as expected because it's the maximum number of stars they can get, and the reviews here too. And we can also quickly create a scatter plot to look at the relationship between the number of reviews and the average rating of a book. Let's do that with ggplot. We'll take the Kindle books data, and inside aesthetics as x-axis reviews and as y stars, and we'll add the points. And then the title, let's use gg title here again, and say correlation between number of reviews and average rating. And or you could have set stars too. There's x table, number of reviews, then as y label, average rating. Before showing this, I'll also calculate the correlation. So it will be Kindle books $, reviews, and the stars, and we say use complete dot ops. I'm gonna be explaining this, and first let's plot this. And now we can see the correlation between them. And actually there isn't really a certain correlation, because it seems like the with the least reviews we also get 5 stars and also 1 star, and the remaining, as the reviews increase, we get most stars between 4 and 5 and not 3 to 1. So it's actually kind of strange. Without confusing ourselves, we can see that the correlation is like real near to 0. This means there isn't a linear relationship between them, which can be seen here too. So for me, I'm really more comfortable with numbers in these kind of cases instead of reading the plots. And lastly, I want to show you how to create a better looking table with knitter and also cable extra. And we can call the cable function and enter top books, and then let's say format HTML and table.ttr. You can look at the parameters yourself or further customizing it. Class, and then we have the table striped. And then we have the caption. Books. And this also comes from tidyverse, so we are gonna be calling that operator to call cable styling, and then let's say full width F in position center, and let's create the table. And it says there is no package called cable extra, so let's quickly install that. While waiting that, I'll go more into the attributes. So the format attribute equals HTML, which means that the output format should be HTML. And then the table attributing means it's HTML attributes to the table, which in this case adds bootstrap classes to style the table. And then caption is self-explanatory. And for the cable styling, it comes basic from the cable extra library to apply styling to the table. And then full width F specifies that the table should not take up the full width of the output, and the position equals centers table within its container. Can also say left, right for other things. And while we wait for that, let's commit the changes. And here we can see the changes to back. Also, don't forget to put center as string, because I forgotten that. Now let's look at the knitted format in HTML. And as you can see here, it looks really nice. Especially you can use the distill article output too, for example, for your research papers. If you want to do it with R Markdown, you can easily put good looking plots like this and your other code. So it will be really nice. And as you can see, this is the table and how it looks much more better than the previous one. And this was all. Lastly, let's look at the GitHub again. Now to push that, I'll be copy pasting this git removed, and then let's come back to here, and I'll be going to terminal and copy paste this, and now the other one, git branch main, and git push u origin main, and when we just load the page again, we'll be able to see all the things here, like our RMD file here. So for example, we could have also pushed it from the beginning too. I just want to show how to change it. For example, let me copy paste this and then just write oops, now run it, and we can see it here. Now we'll be able to edit and then commit this, like done, and then we'll say git push u origin main, and now when we reload the page, we'll see hopefully but we can see. Let me look at the problem. Actually it should work out this way. Let me look at the changes. It tracks the cable styling. Install that packages cable extra, okay. For done. Let me check for cable styling. Actually, let's save it and try again. Commit and finally, and then git push origin main, and then hopefully we'll be able to see. Yes, now we can see it. So actually you can just say git push origin main after the first one. You can say git push u origin main, but after that you can just say git push origin main and it will work just fine. So that was all from the third exercise. See you at the fourth one, where we'll be looking at some geospatial data analysis and plotting them, and it will be really fun. So see you